Okay, so section 6.8, I believe the last section of the chapter, we're going to be graphing some radical functions, okay? I've shown you guys in class how to graph these easily using the parent function and its table. So I'm going to go ahead and draw the parent function and make its table here so that I can have it handy and use it for those three problems up there, okay? The parent function table goes like this, okay? The y values are 0, 1, 2, and 3. You could go further if you want. The x values are 0, 1, 4, 9, 16, 25, and so on. You could go further if you want. That is the parent function table. And it looks like this. If you graph it, here's my x-axis, here's my y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go a little further so I could fit all of those numbers there. 0, 0, 1, 1, 4, 2, 2, 3, 4, 2, and 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. 9, 3. And it looks like that. That is the parent function. The domain is x is greater than or equal to 0. The range is x is greater than or equal to 0. It only exists basically in the first quadrant. Okay? We're going to take this and apply it to each one of these. And it's actually really, really simple. Remember what I keep saying. If something is happening inside of the radical, that means that the x values are going to change somehow. Okay? If something is happening outside of the radical, that means that the y values are going to change somehow. Okay? And look how easy it is after that. Take your new function, make a new table, and figure out what is happening from the parent function, which is y equals radical x. I forgot to write it. Here's the parent function. What is happening from that to that? Anything happening inside of the radical? No, nothing changed, right? So that means that the x values are going to stay the same. It's the same numbers as in my parent function, 0, 1, 4, and 9. They don't change at all because nothing's happening inside. Outside of the radical, it looks like I'm adding 3. That means that my y values are going to change, or they're not going to be 0, 1, 2, 3, but they're going to be plus 3 for each one. So the first one is going to be 0 plus 3, which is 3. We're adding 3, that's what it's telling me to do. From these numbers, from the parent function table, to these, we add 3. 1 plus 3 is 4, 2 plus 3 is 5, and 3 plus 3 is 6, and I'm done. Those are my new, that's my new table, and so my graph will look like this, 3, 4, 5, 6. Okay, so I'm going to draw it here. Hope it fits. Like that. I'm going to have to erase it when I do that one. It's going to be 0, 3, 1, 2, 3, 1, 4, 1, 2, 3, 4, 4, 5, 4, 1, 2, 3, 4, 5, and 9, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, there it is. There it is my new graph. So if you compare it to the parent function, all that happened to it is it moved up by 3. That's what it's telling me to do. Vertical translation up 3. All right, let's look at number 2. Well, you know what? Let's skip number 2 so that I can leave it there for a little while. Let's look at number 3 because it's very, very similar to number 1. So we could do that really easily now. Okay, make your XY table. Okay, what's happening inside of the radical? Nothing, right? From the parent function to this function, nothing changed. So that means that my x values are going to be the same ones, which you should have memorized, 0, 1, 4, and 9. They don't change at all. But my y values are going to change by -7. They're going to decrease by 7, okay? So instead of 0, 0 minus 7, what I'm doing is I'm taking away 7 from these y values. 0 minus 7 is -7. 1 minus 7 is -6. 2 minus 7 is -5. And 3 minus 7 is -4. That's it. That's my table. Graph it, and you're done. So it looks like I need negatives instead of positives in this case. Let me draw my x and y axis. Here's my y axis. And here is my x axis. 1, 2, 3, 4, 5, 6, 7. I'm trying to make it fit. And in this one, all I need is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0, negative 7, right there. 1, negative 6, right there. 4, negative 5, right there. And 9, negative 4 is right there. And here is your graph. It's the parent function, which started here, shifted down by 7 units. That's it. All right, let's do number 2. We skipped. It's this one. So number 2 is what I'm doing right now. Y equals radical the quantity x minus 4. Okay. Once again, start with your parent function table. So let's make a table. We're not doing number 1. Okay, I'm writing over here just so I can have enough space. Number 2. Is anything changing inside of the radical compared to the parent function? And in this case, your answer should be yes, right? The parent function is radical x. This one is radical x minus 4. Now, the way you got to think about this is the opposite, right? Minus 4 doesn't mean to the left. It means to the right. It got shifted to the right, okay? So what you're going to do to the x values is not subtract 4, but add 4 to them. What happens to the y values? Nothing, right? There's nothing outside of the radical. So the y values are going to be the exact same as my parent function. 0, 1, 2, and 3. My x values, though, are going to change by 4. 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. And 9 plus 4 is 13. There it is. And now we can draw our graph. All I want is positives, and it looks like I need to go all the way to 13 to make it fit. So I'm going to make this really big. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's what I need. And on this one, I only need 1, 2, 3. So 4, 0, 5, 1, 8, 5, 6, 7, 8, 2, 9, 10, 11, 12, 13, 3. There's your graph. It's the parent function, which begins here, shifted to the right, 1, 2, 3, 4 units. That's exactly what it's telling me to do. Okay? And that's it for those. Okay? Remember, for radicals, for square roots, you're always going to start with this table, which represents this graph. Okay? So basically, we took this graph and we shifted it to the right 4. In this case, we took this graph and we shifted it down 7 units. Okay, so let's graph a few more that involve a little bit more than just shifting up or down or left and right. Okay, a little bit of a combination of different transformations. Okay, so once again, to begin, I am going to go ahead and make my table, my parent function table here. Ignore this, we're not doing this right now. My parent function table, which you have to memorize, 0, 1, 4, 9. They're really easy to memorize, guys. And 0, 1, 2, 3. Okay. My graph of my parent function looks like this. 0, 0, 1, 1, 2, 4, 4, 2, and 9, 3. So it looks something like that. This is what I need to start with every time, and then transform it accordingly. So let's look at number 4. Okay, make your XY table. Figure out what's happening inside and what's happening outside. Inside of the radical, the x values change. Outside of the radical, the y values change. Okay, so inside of the radical, nothing's happening, right? We didn't add or subtract or anything. So my x values are not going to change. Y values, though, there's a 4 outside of the radical. Is that an addition of 4 or a multiplication by 4? That's multiplication, right? So what we're going to do is we're going to take all the y values and multiply them by 4. And that'll be it. So 0 times 4 is 4. 1 times 4 is, oops, 0 times 4 is not 4, it's 0. Someone didn't learn his multiplication tables. 1 times 4 is 4. 2 times 4 is 8. And 3 times 4 is 12. And that's the table that you need to graph. So we're going to be making this really, well, it's not going to fit. That 9, 12 is not going to fit inside my graph. So we'll get these, okay? 0, 0, 1, 4, right there, and 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. It crosses my table there. This is what it looks like. It's going to go hit that point and keep going that way to hit 9, 12. Okay? So what happened to the parent function to become that function? It didn't move anywhere, right? It didn't move to the left or right or up or down. But what happened is it got stretched. This number stretched it. It's like we grabbed it and we made it longer in the vertical direction. Okay? Number 5, let's look at that one. Again, the steps are the same here. Start with your parent function table and just change it accordingly. Okay? Anything happening inside the radical? Yes, a plus 1, right? That means to the left 1. It doesn't mean to the right 1. So when you change your x values, don't add 1, subtract 1. Let's do it. 0, 1, 4, 9, minus 1. 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. And 9 minus 1 is 8. The y values, 0, 1, 2, 3. What do I do to them? Look at what's happening outside of the radical. Outside of the radical, the only thing I see is this negative 2. Nothing over there. So all I'm going to do is take my y values and multiply them by negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. 2 times negative 2, I'm multiplying by negative 2 by the way. 2 times negative 2 is negative 4. And 3 times negative 2 is negative 6. And there you have it. Okay. So it looks like I have mostly negatives as my y values, so I must make my graph fit that. I'm going to make it go positive x values mostly, and negative y values mostly. So I really need the fourth quadrant in this case. Okay. Here's 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8. That's what I need. Negative 1, 0, right there. 0, negative 2, right here. 3, negative 4, right there. And 8, negative 6. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. And here's what you have. That's your function in this case. Okay. So what happened to this, the parent function to become this? It got shifted to the left by 1 unit. So instead of starting at the origin, it starts here. It also got stretched by a factor of 2. That's why it went this way. And it also got reflected across the x-axis, and that's how it landed like that. Okay, so 3 different things happened to it. Let's look at 6. Same steps. X, y. Figure out what's happening to the x values, what's happening to the y values from your parent function table. In this case, inside of the radical, nothing's happening, right? It's staying the same, which means that my x values are going to stay as 0, 1, 4, and 9. My y values, though, a couple of things are happening. I'm multiplying by 5, and I'm also subtracting 4. So I'm going to do both of those things. I'm going to multiply by 5, and then subtract 4. Times 5 minus 4 for each one of these. 0 times 5, 0. Minus 4, negative 4. 1 times 5, 5. Minus 4, 1. 2 times 5, 10. Minus 4, 6. 3 times 5, 15. Minus 4, 11. Looks like I mostly have positives and positives in both for my x and y values. I do have a negative 4 as a y value, so I must make sure that I include that. So I'm going to draw my y-axis here. I do need all positive x values as my x-axis. So here we go, right here. need to go all the way to 9. Actually, I'm not even going to fit 11, so I don't need to go that far. Okay. 0, negative 4. 0, 1, 2, 3, 4. Right here on the O from the word ground. That's where it begins. 1, 1. 1, 1. 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It's up here past my table. I'm going to stop there because the rest are not going to fit, right? 9, 11 is way up there. So from here, you're going to go up and towards that point and continue increasing. So compare that to my parent function here. What happened to it? First, it got shifted down by 4 units. See that? Down by, it didn't get shifted down by 4 units. Yeah, it got shifted down by 4 units. And it got stretched by a factor of 5. Okay? Actually, first it was a stretch, then the shift. First, it got stretched by a factor of 5, so it became this long function, and then it got shifted down by 4 units. And that's what it looks like.